Now let's try to understand what is happening here. When you talk about filter, what it does. When you talk about map, what it does. We understood what it does in the for each. It takes the object of consumer, but I'm not sure what it will do here. So what I will do is, just to simplify the code, I will remove everything. And also, let me remove all these things so that it will look cool, simple code. Okay, so let's go step by step. If we talk about this filter, and if I say, okay, let me just go to filter. And you can see filter needs an object. You can see there's a parameter. It needs an object of a predicate. Now, what is predicate? I will just go back here, and if I type predicate here, so if I say predicate, and you can see it belongs to a package java.util.function. And if I click on predicate here, predicate is an interface which has a method called test. It returns you a Boolean value. Okay. Now, based on this Boolean value, it will say, okay, it can be either true or false. If from a stream, when you apply a filter for a particular value, if this is true, it will go ahead. Otherwise, it will stop. It's something like applying a filter on a river. So let's say if you have a river flowing and then you have to apply a filter there. And if you want only the pure water to pass, all the garbage will be stuck somewhere. You can do that with the help of a filter. I hope that makes sense, right? Let's implement predicate here. So of course, predicate needs a type you want to work with. And then let me say this is P is equal to, and I will say new predicate. Now this predicate is an interface, so we have to of course define it, but what method it has. So if I go back and if I say quick fix, add the implementation method. So the method name is test. Okay, remove that. So method name is test, and it takes the integer value. And based on some condition which you can specify is it true or false. So what I can do here is I can check if the value t or whatever value you want to have. Let's say the value is n not. I don't like t later. Let's go with n. So if n is n mod 2 is equal to 0, in that case, return true. I can give a tab and I can say else return false. Our problem solved, right? Okay, so if it is true, if the value of n is even, it is true, then if this is true, I will return true or I will return false. And now what I can do is instead of this condition here, I can put p, right? Even that should work. Let's try, compile and run. And you can see it is working. So basically this filter needs the object of predicate, which specifies the logic of when to pass the value and when to stop the value. Now, if I try to reduce this code, don't you think this condition here itself returns true? Then why to write such a big line? We can actually return n mod 2 equal to 0. Because see, ultimately, we need a Boolean value, right? It can be true or false. So we can do this. Also, the predicate itself is a function interface. That means we can use Lambda expression here. So we can remove from here to here. We can remove the entire part. We don't even need to specify the type. And we don't need this curly bracket. We can put an arrow here. And then, since we only have one statement, you don't even need curly brackets. You don't even need a new return keyword. We can write everything in one line. And since we have only one parameter, we can remove this one. And you can see the P is equal to this expression. And whenever you have the expression, or whenever you have P, you can write this expression. And this is what we have earlier, right? So now we know how filter works. Let's see how map works. If I go to map, map needs object of a function. Okay, what this function is. Now function is this functional interface which takes two types. Okay, makes sense. And there's a method called apply. Okay, so what I can do is I can have the object of map, or not the map, the object of function. Now this function takes two types. One is what it accepts and what it returns. And say, let's say fun, because that is fun, and new function. And again, this is a function interface which has only one method. Let me just add that here. So this is a method which we want to override, which is apply. Now what I want to do, whatever value you get, let's say instead of TV, let's say n, whatever you want to do with this n, it will just apply that value. So let's say for this n, what I want to do is I want to return n into 2. So whatever value I'm getting, I just want to double it. Again, as I mentioned, logic can be anything, but I'm doubling it here. Okay, makes sense. And we also know that this is a functional interface. Okay, first of all, let me take this fun from here and put it here. So we can say fun, and let's see if that works. I will say compile and run, and you can see we got 24. It works. What we can also do is from here to here, this is a functional interface, so we can remove this part and we can use Lambda here. I'll just do that quickly. Now we have mastered Lambda and we have only one statement which is returned, so we can remove that. We can remove this curly brackets, we can remove this integer, we can remove this brackets, and this is what we got. And now we know wherever you have fun, you can write this, and this is what we had before. So we don't even need this, right? The same thing can be done for reduce. If I click on reduce, you can see reduce takes two parameters. One is the type and second is the operation. Okay. Now what is this binary operator? So binary operator basically is, it extends by function. By function is a method called apply. Okay, let me just simplify this for you. I know this is a lot of implementation there. Let me simplify this thing. Now, when you talk about reduce, how do you reduce a value? Example, let's say if I ask you to add three numbers, let's say 1, 2, 3, how will you add them? Now, in your mind, you're doing this. So if I say 1, 2, 3, and let's say 4 also, how will you add them? Of course, you cannot add all the values at the same time. You add two values at the same time. So first of all, you will add 1 and 2, which will give you 3. Then you will add 3 and 3, which will give you 6. And then you will add 6 and 4, which will give you 10, right? So you add two values at a time. Or maybe if you want to simplify this, you can start with 0. So you can say 0 plus 1 is 1. Then 1 plus 2 is 3. Okay, so you have to start with the initial value. Remember when we created int sum, we have assigned the value to of sum is 0. That is this 0. And every time you will simply add two values. So if I want to add two values, can I say this is C and E? The carry, because see, this 1 is a carry here, right? This 3 is a carry. This 6 is a carry. This 10 is the output, of course. But this 1, 3, and 6, they are carry, which can be represented with the help of C. And then we have this E, which is the element, right? C and E. And what you're doing is you just have to say C plus E. And that's what we have done here. The 0 is the initial value, what you want to work with, this value. And then the C and E are the two variables which is going to work with this thing. And the C plus E is the operation. It's that simple. Okay. Of course, you can do this with the implementation, but I think you got the point, right? So stream is cool, right? It works with, we can apply multiple functions here. In fact, let me show you one more thing. What if I don't want a int result in between? I want a stream itself, but I want the stream to be sorted. So I will say integer, and I will say sorted values. But I don't want to apply reduce because reduce will give you one value. I only want to filter them based on the condition, and then I want to say sort. That's it. The moment you say sorted, you will get a sorted stream, and maybe you can also print this values directly instead of using a for each. Let's try that. Compile and run. Oh, we have to use for each. Okay. So I will say sorted values dot for each, and you can say whatever value you get, just print it. Okay, let's try compile and run, and you can see we got the value in sorted format. So basically we have multiple methods to work with. In fact, there is one more thing. What if you want to do the filtering but with multiple threads? By default, you have only one thread, right? What if you want to use multiple threads? In that case, there is another function called parallel stream, which will create multiple threads for you to make this faster. The only thing is, when you say sort, parallel stream doesn't make sense because sorting will need all the elements together. So don't use parallel stream when you want to sort. But yes, if you want to filter, parallel stream works. Okay, so yeah, that's how we use Stream API, and I hope you got the idea about map, filter, and reduce.